Hello, thanks for joining another roundtable discussion for artificial intelligence and machine learning adoption, so-called ML ops. In ML ops, you have much of the considerations that you have to be aware of early and advanced, and make plan accordingly. Not necessarily a just-in-time logistics, but rather a proactive logistics that allows you to deliver, develop, and create solutions on time, right? On time that is scalable, sustainable, and has the business justification set behind it. Same as financial justification. The hardware conversation is picking up steam as we speak day in day out about artificial intelligence. The hardware has been a chokehold point for artificial intelligence for a very long time. And what I mean by that is that when you have so much demand and the hardwares are not able to keep up, hardware slows down this AI capability. And this is not necessarily something that is going to stop anytime soon. This will um, uh, present this challenge will present itself as we move forward. As we move forward, we'll be able to see how these challenges will scale. These challenges have been scaling for quite a while now, but now we're coming to an inflection point where this will become more into the surface level conversations, just like we're having with Chat GPT, large language model, how impressive they are. And there's these hardware that will slow these capabilities down, because at this point, no matter how many users the Chat GPT has, it's not enterprise level usage, right? So when you have individual or small marketing teams that are using large language model, but if you want to integrate them into a higher scale for bigger use case purposes, you really have to start thinking about the hardware, and the data is very, very important and relevant, because you know because you're waiting for hardware does not mean data is going to wait for the hardware to come, right? So you have to figure out a way to collect this data. You really have to be proactive and multifaceted approach, right? You have to look at the data, and you have to develop the software, and then you're hoping that hardwares are available for you to use when you have to process this data using the software. So the conversation of roundtable discussion in the first 5 or 6 episodes, we talked about the fact that it's a financial justification. What does the cost structure look like? What are some of those financial justifications that you have to really consider and address as you move forward? So when we are looking at the recent news cycle that is about the hardware, and I can point out a few, but the top one is AI PC, right? It's an AI PC that is a PC plus Copilot by Microsoft, where the hardware is built in such a way the NPUs are able to process amazing amount of data in real time. And when it's processing that much data, it's able to use voice AI just like it would use computer visions all at once to provide these multimodal services that is truly, truly are impressive. And one of the concern is that how fast can we develop these laptops for enterprise levels? How fast can we get them to the consumers? And how can we, have millions and billions of them in short few months or few years, right? Because once you have a hardware that is AI based and is as impressive as the Microsoft laptop, uh, you'll see a race, and that race means we will have to extract resources again in multiple layers and all over the world to put these hardware together and get them in front of consumer to meet that demand. So supply and demand and hardware is synonymous, as in, just because there is a need for a hardware, it doesn't necessarily develop because there's no demand for it. But when there is a demand for it and the supply chain doesn't have enough of raw materials to develop these tools, you have another sort of problems, right? So this is a lengthy conversation. If you're interested, we can set up a time, go over these topics, and very tailored and personalized to your use case, because these hardwares are pushing this hype cycle down the slope, right? The hype cycle is at, in my opinion, it has peaked, and it's about to go down, right? It's about to go down because for years I've been talking about the fact that history repeats itself. And the last time we had the same AI hype happened, it was the history says that, it was the hardware, right? Not having the ability to process that much data all at once. But now, in this time in the history, we have that much data processing possible all at once. But now that the demand is so high, supply will not be able to catch up or ramp up as fast as we would like it to be. Uh, Prove me wrong, but I'm okay with that because that's the concerns that we all have based on the raw materials that we don't have available for these semiconductor chips, right? Specifically, if you want to go even higher, understand the geopolitical situation where, where are they being manufactured? How are they being manufactured? And who are they being manufactured for? So when you have a good control of these hardwares, it creates a problem for the people that are trying to process this data, and they want to process it today and not be on the line to be the fifth one in the line to develop these process 5 days later, right? So hardware, what you need to know is that uh, there's different types of hardware, different needs of hardware that's coming down the pipeline, right? Because of their supply chain plan and supply chain routes is shifting locally. So you don't necessarily have to design it in California and ship it off to the Pacific Ocean on the other side to have it manufactured. You can design it in California and manufacture it in Arizona. And if it's manufactured in Arizona, you can drive from Texas and pick it up and put it inside of a device, right? So wherever it's being manufactured, where it's being designed, the distance is shrinking. And that's the purpose of all the efforts that US government and Intel and Samsung, TSMC, they're all moving their fabs into a location where it's easier to get to, but it also has less geopolitical tensions that consumes that whole supply chain, right? Um, there's multiple levels of hardware that you can engage with, but they all serve different purposes. So if you're in a certain industry, you don't necessarily have to have GPUs available to you all the time, but you will interact with GPUs, you will interact with FPGA one time or another in order to have your supply met, right? In order to have your demand met, excuse me, your demands being met through CPUs, GPUs, or even sometime FPGA. These systems of NPUs that are coming in line, they're going to be really utilized in tons of hardware that we haven't previously even thought of using. So once it goes up to a point that the prices can come down, we're yet to see how many hardwares can we implement this NPUs into, right? And who will deliver them that fast, and how can we scale and sustain them over time is yet to be seen. So that's the sort of the emerging trend that you're seeing in AI hardware, and we really have to talk about the strategy behind it, right? So choosing the right sort of hardware means you really have to know the data that you have, really have to know how the software will process it. One of the things that I was thinking about, in order to really address this concern, is that when you have a need to scale and that is your priority rather than just to sustain, because there's two different outcomes when you have sustainable AI solution only, not scalable one, right? Two different outcomes. If you have just one narrow pathway that you want to take versus say, how do I stack more solutions of AI from the AI that I really have a lot of success with, right? If you look at it from that perspective, one is sustainable, one is scalable. But if you're able to sustain and scale, that's where the magic happens. That's the hard part of engaging with data, software, and hardware. If the presentation is for you to take away anything, what needs to be taken away is that the fact is there's a time that you really have to value, because it's all about strategizing. At what time did you create this AI, and what time did you release it? It's all about time, right? Because you might have a competitive edge today, but if somebody else has a better hardware than you do 2 years down the road, they will have far more competitive edge than you will today, right? So there's different timing strategy that you have to understand, and then what's sustainable and what's scalable, right? Combine all three of these recipes together, you have a good outcome or a bad outcome, right? So time, sustainable, and scalable AI, right? How does that impact? So that's the main goal of this presentation in a 30 minutes long discussion. Like I said, if you're interested, I'll spend more time with you one-on-one as you need to go through each of these steps. I will skip through some of these presentations. Like I said, it's only 30 minutes long presentation. What I'm thinking is that if you watch these videos, you will take some time and do some research and try to put the threads together between what it is that you know, where does your subject matter expertise is, where your domain knowledge is, and thread it together into what you need to know, which is the hardware, software, and data. If you already know these industry, I would always encourage that you dive deeper into another subject matter expertise outside of, say, hardware, software, and data, because you already know these domains. How do you integrate the subject matter expertise for another industry and see how they apply with these discussions that we're having? So latency and the memory, the storage considerations. If you want to go down that rabbit hole, one thing that you will really have to start addressing is the edge cases, right? Is the device local? If it's local, how do they process the data? What's going to happen to the cloud if everything is stored locally? Um, that's the type of questions that comes up these days because of the edge, because of the shrinking of the hardware, as in we're going from the semiconductor chips that are 125 nm to 2 nm, and in between there's a lot of these hardwares that will go obsolete eventually, because we no longer need to have that many semiconductor chips around our environment to have data processing piece by piece, right? We can process all at once in one single plate, right? Or one single hardware. So you have all these questions that are coming up. They're not necessarily the biggest concern. Your concern is the data that is yours. How small is it, and how can you protect it? How's the safety, security, and privacy of your data versus what's in the cloud is not necessarily something that you really care that much about. I mean, this is a future case, not necessarily today. So the question of, like, local AI or edge AI, and then distributed AI, these are sort of the terminologies that's coming to the gear, because you've seen the Copilot AI, right? The PC that is Copilot, and then you're seeing large language model that is being utilized in Apple device, right? Apple released their Apple Intelligence for their iPhone 15 or higher versions to say, from now on, if you like ChatGPT, it's sort of like interacting with ChatGPT in real life, real time inside of your iPhone without really doing much to the hardware, right? What's happening to those data? Where are they being stored? Are they being stored locally in your phone using an A16 chips that has a really massive amount of data processing power for a small device? And if it's not being processed in your phone, how is it being processed outside? Is it being processed in a silicon in Apple server farm somewhere, or is it actually going up to ChatGPT? And what's the privacy like once it is being reached out to by Apple to ChatGPT, right? So there's a lot of these information that is being addressed, but the idea is to say it is masked. The IP addresses are masked. That means ChatGPT or OpenAI will not be able to trace back the question to you, right? So you have a lot of privacy there. That is what's being told. That is yet to be seen, but as we move forward, we really have to start thinking about the latency, right? If the data is processed right in there in your device, the latency is very short. So, if it has to be processed through ChatGPT, it probably will take a few microseconds longer than what we are used to in device data processing. So as this is happening, like you want to address some of the things that you have control over versus things that you do not have control over. And that's what I mean earlier about the timing and the strategizing, right? You really have to strategize. You have to really know what's more worth it. Is it sustainability or scalability of these AIs? And how fast or how slow can this AI be? And how do you make a good business justification to go after these use cases? Uh, one piece that is not listed here is the NPU, and that's what's going to change the game, and that's what's changing the game today, as we are talking about the A16 chips as a neural network chips that is specialized on neural network, as in its capability to take an input and provide that output through multiple variables that it has to test out and say this is the best probable output that the user is looking for. And as it does that, it learns over time that this particular user has these sort of output requirements, and it will memorize and learn from these and execute better and better decision making capability as time passes, right? Not necessarily that it will scale, but it will be able to sustain because of these new learned experiences. And we'll talk more about scaling eventually, but point is, let's talk about some of these hardwares, and these hardwares, the NPUs, are processing data and learning from those data. And that's very important in AI, because there's no point of having a system that has to uh, relearn fresh every time. We can dive a little bit more deep into that as time passes. Um, what's one of the you know the thread that is connecting all these AIs inside of an iPhone or AI inside of a PC is that you have a wide ranges of tasks, and if AI does one very well but not the others, it really needs a transition. It really needs the encompassing of multiple tasks being conducted by an AI, sort of like how we used to have to go to a library and leave our home, put our shoes on, walk to the road, and then either drive or take the bus, or walk ourselves to the library and go to the library and go through the process. These are tons of tasks that, if we are to chart, if you make a list of it, um, we don't do that anymore. The library is literally inside of a laptop, and that library, we're able to access it in few clicks. So when you're looking at AI from that perspective, the wide ranges of tasks, where does AI does it very well versus what we do today, right? And where does AI take over mainly, or does AI take over multiple of these roles and say you no longer even have to think about going to the library. You don't have to click to get to the library. You communicate with me to talk about what it is that you need from the library. Just like you would ask a librarian where this book is located, you'll be able to talk to an AI and have this AI communicate back the information that you're looking for. So there's lots of these tasks that we really have to think about and process through each of the titles or the roles that AI will take. And there's a lot of complexity to it, but there's not much time to discuss all these topics. And we can definitely, like I said, set up time and talk through all these capabilities, one topic at a time. I'm going to skip through some of these capability, the hardwares. But if you were to look at what's being performed and who needs it, what are the return on investment? If you were to buy a $10,000 hardware and you have petabytes worth of data, and those petabytes of the data, once you process it, who buys it or who uses it or how is it being utilized, what business process does it fit into that it creates revenue or it creates demands, right? What sort of demand signal did you buy those 10,000 hardwares for, $10,000 worth of hardware for, right? You have tons of these questions to answer, but there's always these frameworks that we work with to address those very quickly, right? Because you can go down the rabbit's hole of asking 20,000 questions, or you ask three questions and frame the demand signal based off of those three questions using a small framework. Um, if let's say, for example, you're listening to my conversation at this point and you're saying, this is super confusing, I've never heard of these terminologies, these are the terminologies that I deal with on a daily basis. Well, I feel the same way about a lot of the other industries, right? Some other industries that I'm trying to learn, and I said, well, I never use these terminologies, and once I hear it, it confuses me a lot. But every industry has a small framework or a method to understand everything you need to know, right? In this case of AI and the hardware, there's two types of hardware. You really have to think about it just from these two perspectives. If you think about from training versus inferences, it all makes sense, right? Because training is what the data has gone through, right? Data has been trained to perform. And once the data is ready to perform, unit inferences, which is that between you to the trained data set, how do you get to that trained data set and ask it a question and get the answers, correct? So if you think about just training and inferences, that's all you really need to know, why these hardwares are so complex, and how to solve these hardware questions as days and months passes, right? Eventually, we'll come to a point we will see more of these need for inferences development rather than always just training. And we have tons of training data at this point. We've been training a lot, and it's becoming very expensive, but hopefully it will plateau or hopefully it will come down in price for the inferences purposes, because we really want to be able to use this data and keep training more and more of this data without the prices shooting through this roof. So again, training and inferences. Just remember those two words if you're not familiar with some of this terminologies I'm discussing here. I'm going to skip this one, but think about edge AI hardware. That's what I meant earlier. When you have an AI that is not necessarily in your house, in your device, in your zip code, it is located somewhere out in the world that you have no idea where it's coming from. The edge AI hardware will storm the world when it's ready, like it is today. It's being implemented inside of a device in your home for your personal use, privately, safely, and securely. That's what's being asked for, and that's what's coming down the pipeline, and that's what we're going to get. So you really have to think about, like I said, strategize with the time. Part of that strategy is the right hardware. What sort of workload, budget constraint, and scalability needs do you have, and how do you answer those through a small frame, so that way you have a far more confidence in your due diligence of how it is that you will spend your money or spend your time and effort into these topics. We're coming down to like last minute of this presentation, but I want to really key into the future outlook here and talk about what I mentioned earlier about how these data is trained and how they are processed, right? So when you have tons of data and you want to train those data, as you train those data, visualize a dance floor, right? A single dance floor, but it's connected to hundreds of other dance floor. This analogy is about training to learn how to dance, right? But you're learning how to dance in multiple dance floors, right? But in order to have communication between the thread between each dance floor, you really have to do a lot of this manual hard work. So when you hear AI, AIs are being trained in those dance floor, right? But there's a need to coordinate why this dance floor has a relationship with this dance floor, right? So you have a lot of this dance floor and they're interconnected. So if you have interconnected dance floors and you have thousands and millions of these dance floors, it's really hard to coordinate between each of these dance floors. But what if you are able to create a single dance floor where you had millions of dance floors all stuck together? There is no need for coordination. Everybody can see each other and everybody can learn from each other's behavior and mistakes. And that's important to understand, because when we're talking about inferences, the cost of inferences and cost of training data, it really is reduced by these bigger dance floor where the AI can learn how to dance, right? Or AI can learn how to do their performance or whatever that is they're performing. And then for you to be able to tap in to that train data, you are able to extract those information far faster in a package that doesn't take a lot of stitching. Let me say that again. If you have a dance floor that is interconnected, there's no threads in between. Everybody can see who's training on what and how things are training, and they can all train on the same topic. When you tap into it for inferences purposes, you do not have to get stitched together information. You can have it all at once, and if you can have it all at once, you can also have it internally in your internally in your NPUs that you paid for, you bought for, and it's private to you. And the biggest shocker of them all is that these AIs are not internet-based AI. They will probably have to be connected to internet eventually, sooner than later, but they can perform probably with high accuracy and most confidence without having internet connection. They do not have to be connected to a server. They do not have to be connected to on Wi-Fi. So if you're looking at an edge case, edge AI hardware, these systems will be able to work in disaster location, middle of the Pacific Ocean, with high capability, like they would with internet, and they'll be able to keep performing without internet for a long period of time. So that's the future outlook that you really have to get excited about, start strategizing for, and really start thinking about, okay, if I have the time today, what do I do with my time? Right. If I have the need for sustaining an AI system, how much time do I have? And is this time being well spent for things that I'm thinking, oh, well, it will come down in the future, so I'll just wait. I think if you're waiting, or even if you're not waiting, whatever your situation is, you really have to put together a framework and understand AI from multiple perspectives. And if you're looking at the technology, the technology is really not here. The hardware is really not here. It's not enterprise level. It doesn't really scale and sustain. Well, that's the delivered side of things, right? That's deliverable. If you reverse engineer from what's being delivered, think about the process, right? This process is really not in your control, right? This process is not really in your control, because this process has multiple organizations and multiple teams involved. But one thing you can do is say, behind each process, there's people, and I have my own process, but I have my own people. How do you engage with your people? How are you able to understand your people's capability, right? The intensity that they have, and grow that team so that way you can engage in the right opportune time, because you've seen all the stars lining up, and you're able to engage, and you're able to engage with the sustainability and scalability in mind, right? Because I hate to say this, but there's lots of these companies that are hurting right now because of what just happened in the last few weeks, right? These companies really had lots of promises and lots of hopes, but uh, because of other enterprise level success, these companies are really getting the rug pulled out of under them, and that's a tragedy, and that's something that we will have to deal with. We're already dealing with job losses, but if you have a team and you want to develop your people now, and don't wait to develop them after you see the technology working and performing. It's really about developing your team, not just for AI, for the data capability purposes. So if you want to really have sustainable and scalable magic happen over time, you really have to start with the people. So it's the people, process, and technology. You really have to start with your people. Engage with your people in the right way so they understand AI for your business for your business process and your workflow, and use those use cases to upskill your workforce, so that way they can benefit from these sort of information ahead of time, and they're ready to target, ready to engage when the opportunity comes around. So with that, thank you so much. Looking forward to the next roundtable discussion. Until then, take care and goodbye.